Hi, the topic that we present is quarter and curves in polar. My team is me, Janet Moreno Lopez,
Carla Andrea Bautista Nicolás.
José Miguel García de la Cruz.
The polar coordinate system is a two-dimensional coordinate system in which each point in the plane is determined by an angle and distance.
the polar system. The Cartesian plane is a rectangular system because the coordinates of a point geometrically they describe a rectangle. If we make this point represent a vector of magnitude r, starts from the origin and has an angle of rotation. The name is theta. We will have another way to define a point. It will be enough to denote the point in this way. Mention the value of r and the value of theta. This is going to do it indicating the order pair theta and r. In this case, it said that they are coordinates.
To locate the coordinates, we need the trigonometric circle, which goes from 0 degrees to 360 degrees. In this circle, the bulbs of the angles are observed in from polar coordinates, in sexagesimal degrees, and in radians.
Coordinates are as follows: x squared plus y squared equal to r squared, where r is the distance from P to the origin. Clear, r is equal to square root of x squared plus y squared. To find the angle is the inverse tangent by over x. We have the Cartesian coordinates. First step, we identify x and y. Following, we substitute in the equation for r, and it is equal to 1.3 or root of 2. Next step, we take the angle by substituting, and it gives up negative 30 degrees. And as result, our polar coordinates are the root of 2 point minus 30 degrees.
Cartesian to polar formula. Let's start to explain. Look the example. Is 2 and 2 square root 2. R is equal to square root 2 to square plus 2 and 2 square root 2 square. The result is 2 square root 3. Theta is equal to tangent exponent minus 1 y divided by x. Theta is equal to tangent exponent minus 1. 2 square root 3 divided by 2. The result is 60. Finally, the result is 2 square root 3 and 60 degrees. Polar to Cartesian formula. R and theta is equivalent to x and y. For obtain x, the formula is r cosine theta. For obtain y, the formula is r sine theta. Let's start to explain. Look. Square root 3 and 2 pi divided by 6. Pi is equal to 180. Theta is equal to 60. To get the result for x is square root 3 cosine 60. The result is square root 3 divided by 2. To get the result by way is square root 3 sine 60. The result is 3 divided by 2. Finally, the result is square root 3 divided by 2 and 3 divided by 2.
Curved in polar coordinates. A curve in polar coordinates the graph of a function of its form r equal r0 with the I any interval. Circumference. This new function present used with a shape keynote to hold, and it is precisely the circumference which will be found in the polar graph with the following function. Cardioid. The following is the type of graph that is called a cardioid. For this example, a cardioid symmetric with respect to the right is present. 3 left rose petals. Deduction of the formula for the are enclosed with the curved in polar coordinates. R equal R codes 3T keynote. As the 3 petal rose, the definite integral that served this problem is 6 1/2 of the function squared. The limits of integral and b6. Polar rows in the name give to any member of a family of curves with the equation r0 equal c2 key 0 for resembling a flowers with petals. The formal spiral, a keynote as the parabolic spiral, is Archimedes spiral with me equal to has a polar equation.
We will perform two graphing exercise of a polar equation. Example 1. We will use the trigonometric cycle. We have the equation of r equal to 2 sine of theta. We table to find theta and r. We take the sexagesimal values of the trigonometric cycle for theta. We substitute in the equation and we have a result 4, 2, 1.4, 0, minus 2, 0, 1.4, 2, 0. Finally, we graph. We put the equation and we obtain the line. We have a rose with 3 petals. Example 2. We have the equation of r equal to 4 cosines of 2 theta. We table to find theta and r. We take the sexagesimal values of the trigonometric cycle for theta. We substitute in the equation and we have a result 4, 2, 0, minus 2, minus 4, minus 2, 0, 2, 4, 2, 0, minus 2, minus 4, minus 2, 0, 2, and 4. Finally, we graph. We put the equation and we obtain the line. We have a rose with 4 petals.